I'd like to present you with a big picture view of physics. And for myself, I had a lot of trouble learning physics because it occurred to me as a whole bunch of facts that were somewhat related, but oftentimes I couldn't quite see the forest because of all the trees. And so this big picture just presents what I believe are really the two ideas that you are looking at all the time in physics. So in my mind, physics is really the study of the physical world and how it changes with time. And in that study, there are essentially two really big ideas that are occurring over and over. The first is that mass, energy, and momentum are conserved in the physical world. These things just don't sort of pop up and then go away. And the second big idea is that when you look at how these things change with time, there's a principle called the superposition principle, where you can essentially sum the effects of the individual changes to get the total change. And this comes directly out of the conservation principle. So these are the two big ideas I see in physics: the study of the physical world and how it changes with time. So what do you need to know to study the physical world? Well, you need to be able to quantify position of an object, the mass, momentum, and energy. By the way, I'm using a notation where this arrow indicates that it's a vector quantity, meaning it has magnitude and direction. And this icon indicates that it's a scalar quantity, meaning it just has magnitude. So in the study of the physical world, if you wanted to know how position changed with time, what you'd see is essentially three cases. This is the whole field of kinematics. And three cases are essentially 1D, where gravity is largely ignored, and you have the position, the velocity, the acceleration, and time to describe what's going on in a linear motion. Now, in a 2D motion, those same quantifiers turn into vectors, and in this case, gravity can't be ignored, of course, because it's acting on the body that's in motion. The next case is rotational motion, and in rotational motion you have rotational vectors that are equivalent or analogous to the linear values. So that you have angular position, you have angular velocity, and angular acceleration. And there's a special case in the rotational motion, in my mind, where you have constant angular speed, and it's a special case because you have a linear velocity with a constant angular rotation or angular speed that results in a linear acceleration towards the center of the circle, and that's of course called centripetal acceleration. So to look at how position changes with time, we use the study of kinematics, and these are all vector quantities. So how would we deal with the changes in mass, momentum, and energy? Well, for the changes in momentum, you might recognize this as essentially the Newton's second law, and that is that in a linear situation, force equals mass times acceleration. You have a very similar situation in rotational motion, where tau, torque, equals rotational moment of inertia times angular acceleration. These are also vectors, but these are just very similar equations. Again, we're dealing with vectors, so you might realize that one of the skills that you need is to be able to add vectors and resolve them using trigonometry into their component values. Another skill that you'll need is to be able to analyze forces into what's called a free body diagram. And on this diagram, normally we represent the mass as a point mass, and we superimpose the forces onto that point mass, and use that information to apply to the motion, which is maybe a different diagram. It would be a kinematic diagram, and in this diagram you draw a reference frame for yourself and indicate which which are the positive orientation of the directions, and you draw only acceleration and velocity on this diagram. And you'd write your constitutional equations, such as the sum of the force equals the mass times acceleration. And you combine this information with the free body diagram to determine how forces affect the motion of an object. What's left is energy, and looking at changes of energy with time is equivalent to looking at power. So the study of the physical world involves being able to quantify the position, the mass, momentum, and energy, and then looking at how those change with time. Again, there are two simple principles. One is the principle of conservation of these quantities, mass, energy, and momentum. And the second principle is being able to superimpose the rates of change, the individuals, to get the sum total of the effect. So this is the big picture of physics. So this is the big picture of physics, and I hope this helps somehow.